Okay, so we're going to learn how to do growth accounting, but first today we'll learn how to construct the capital series first, and then based on the constructed capital series, I'll show you guys how to do growth accounting as well. Okay, so we're going to use the growth accounting method developed by Kehoe and Prescott. The model features an aggregate Cobb-Douglas production function, not unlike the ones that we've been using in class so far. And then there's a way to rewrite this production function where you can write GDP per working age person. You can decompose that into three components. The first term is a term that relates to productivity, right? So, when you have growth in GDP per working age person, how much of that is coming from improvements in productivity? How much of that is coming through improvements in capital? The more capital you have in your economy. So how much of it is coming through capital accumulation, and how much of it is coming through employment? So depending on the type of data that you have, this could be hours per working age person, or if you don't have aggregate hours work data, this might be employment. So what fraction of the working age population in that economy is currently employed? Okay, so you can decompose growth into these three components. Now, this decomposition is useful because when a country is on a balanced growth path, it's typically going to be the case that productivity grows at a constant rate and the capital to output ratio is typically constant, as well as the participation rate or the hours worked, right? And so this is a very useful decomposition. Okay, but in order to do this decomposition, you need to have capital data. And so if you want capital data for many countries over a long span of time, normally you have to, as I explained before, you're going to have to construct that series. You typically are able to get good investment data, but you don't always have good capital data. So first, we're going to have to collect data for investment, GDP, working age population, and employment. And for constructing the capital series, you just need the investment and the GDP data, okay? And so once you have the investment, how do you change that into the capital series? Well, you need to use something called the perpetual inventory method, right? So X here is investment, and capital is your current stock of capital. So some of that depreciates. That's this delta. And so you might have like a capital stock today, and then depending on the type of capital in that economy, the depreciation rate might be something like 5%, it might be like something like 10%. So it depreciates over time. And then XT is the new investment. So together, there's the old capital stock that hasn't been depreciated, plus new investment, that forms the capital stock tomorrow. Okay. Now, we have the investment data, like I said, I'm going to show you guys where to get that. But once you have the investment data, and once you have some capital stock data, then you can, if you have the capital in like 1960, equipped with investment data from 1960 onwards, you can construct the entire capital stock. But nobody's going to tell you what the capital stock for 1960 is. Okay, so there's ways that we can estimate that. So one way to do that is kind of utilizing this fact that the capital to output series doesn't change that much, especially for countries on a balanced growth path. And so basically, what you might want to do is say, I need to initialize the capital in 1960. Well, here I have the capital to output ratio in 1960. So because I know output in 1960, I have that GDP data, but I don't have the capital stock in 1960. So how do I do that? I'm gonna make a guess. I'm gonna guess, it can be any number you want. I'm gonna guess that capital in 1960, let's say like 3 times GDP or whatever it is. I have some guess. And then I'm going to use the investment data to construct the entire capital series. Okay? Then I can calculate what the average capital to output ratio is from 1961 to 1970. Right? And say that number is like, instead of 3, it's 3.5. Right? So then I'm going to use that number to then recalculate the initial capital stock and do it over. Okay? Now, if I had to do this manually, it would be very time consuming, but we can use Excel, we can use R to do this very, very fast. Okay. An alternative way, and so this is kind of a guess, right? And so you want to kind of check whether this makes sense. So let's try to see if we can initialize the capital stock in an alternative way, which is to rely on the fact that, along a balanced growth path, the aggregate capital stock grows at a roughly constant rate. Okay. So again, I'm going to guess what the capital stock is in 1960, then use the real investment data to calculate the capital series. And then I can calculate, and here it's called a geometric average. So this is just, the average growth rate over the next 10 years, right? So if the average growth rate over the next 10 years is 2%, but given my initial guess at the capital stock in 1960, it grows by like 20%, that probably means that my initial capital series needs to be higher, okay? So that's another way to initialize the capital stock. Recapping what I just described, start with any guess for the initial capital stock, and it can be anything. It can even be 0, okay? Then use the investment series to construct the capital series using the law of motion of capital here. And then update the initial guess, either using the capital output ratio to help you pin down the initial capital stock, or using the growth rate of capital and relying on the fact that the growth rates of capital are typically pretty stable, right? And then you repeat until you converge. So if you can do both, you can do one. In your problem set, I'm going to have you guys do both, and then you can compare the two to see how reasonable they are, okay? So after showing you guys how to construct the capital series, I'm going to show you guys how to do the rest, okay? One of the first things that I like to do, I like to clear the environment, clear workspace, okay? And we saw that this was the command to do that. And then I'm gonna need to load necessary libraries. So I'm gonna just do tidyverse. And it's predicting that I'm gonna want to read Excel, right? And for now, I won't install any of these other ones, all right? All right, so now I need to build the capital stocks. And first, I'm gonna want to load GDP and investment data from OECD quarterly national accounts, okay? Okay, so if I go to this data OECD website, you can search for a lot of different things. I search for quarterly national accounts, and then there's this for developer API. I'm gonna click on that. And actually, if you learn how to use this API, it's like super convenient. And it's actually really easy, but it does take a little bit of time. Okay, so here, now I'm gonna access these quarterly national accounts. I still need to tell OECD, like, for what country, for what is the object that I want, what's the time frame. I need to tell it these things. What currency do I want it in? So you can go over here and you can say, okay, I want annual data, and I want it to start in just download as far back as it'll take you. It's in 1960 is the first year that you can choose. And then let me say 2025. I need to press apply. Now, I don't want to do any adjustments. Normally, if you download monthly or quarterly data, because there's seasonal variation, and usually when you download data, you can choose to have it seasonally adjusted. And so normally you want to do that. This is annual. I'm going to use annual data, so I don't need it to be seasonally adjusted. So I'm just going to skip adjustment. Reference area is where you get to pick the country. You can download all the countries, or you can just download one country, right? So that's up to you. So I'm going to unselect all, and then I'll just show you guys as an example. Korea, you can select that. Apply. Institutional sector, you can do total economy. Apply. What is the object that I want? I want to download GDP right here, GDP. But I also want investment. Okay. Now in this document that I have here for growth accounting, constructing capital. See, when using OECD, gross capital formation forms investment. When using IFS, it's gross fixed capital formation plus changes in inventory. Okay? So when using the OECD, I can just do gross capital formation, which is investment. Okay? So I go back over here. I want to download GDP, but I also want to download gross capital formation. Apply. Okay. So here, I'm going to do national currency. Apply. So this is going to be in Korean won. And then the price base, I'm going to want, I told you guys to do nominal. That's what current prices is. It's not real. I'm going to download the deflator and make it real myself. Apply. I'm not going to do any transformations. And let's see what that data looks like. I can do table. Okay. So I have from 1960 onward, this is for South Korea, I have GDP, and then I have the gross capital formation here. Okay? All right, so that's what you need. So you go over here, and then you click download. Now, there's something really nice, this developer API, and it takes a little bit of trial and error, okay? But I'll show you guys how to do that here. All right. This is giving you basically the online address to this data. And then once you learn, because they have a way of structuring this address. So for certain things, like, if you want like USA data instead of Korea data, you see how in this code there's KOR? We just replace this with USA, then it'll download for the US data. If you get rid of that altogether, it'll just download all the data for all the countries. Okay? So you just kind of have to figure out, and there's documentation, you just have to read it to kind of decode this address. And so I just have this address right here. This is something I just copied and pasted. I added this last thing just to add the format. So the format is CSV file view with labels. And then all you do is use read.csv, this URL, and then it'll just download the data. Okay, let's see what happens. There you go. So now I have this OECD Q&A, and it's a big data set. And it has lots of different things that you don't need all this stuff. And in fact, the address the URL that I use is the one that didn't have the KOR. So this is downloaded. It went ahead and downloaded the data for all the countries. Okay, so this is Argentina, Australia, Bulgaria. It has for all the countries. So it's like super convenient. So you didn't have to go through and do all that. Okay. And then it has everything that I need. It has the GDP. It has this is the gross domestic product, and it has the gross capital formation, and all that stuff is already there. Okay, so I encourage you to try using the developer API. This, by the way, this kind of data access technology is not only used by OECD, but for any kind of major data source. They all have this. It's so convenient, and once you figure out how to use this, okay? So for you guys, either go into the OECD, and I showed you guys how to access the data and download as a CSV file. If you want to take the time to learn how to use the API, I recommend it. But if you don't want to do that, you can just go and download the tables, and then you just need to store them somewhere. And then you'll just need to say, hey, I want to read this. I want to read this CSV. This is the directory where I'm at. I have it data and then raw. And then I've put all there's the OECD deflator data set, there's the OECD employment data set, the OECD population data set, and then the OECD Q&A data set, right? So if I click on this, this is just, what I just showed you guys at the very beginning. This is, I did the same developer API. I downloaded all this data, and I've just stored it as a CSV, okay? And this has, like I showed you before, it has, Argentina, it has all these other countries. Australia, Bulgaria, Brazil, Canada, there's all these countries. So I can do this analysis for Korea, but all I need to do is say, instead of choose Korea, choose Switzerland, and I can do it for Switzerland. You see how like time saving and convenient this is once you learn how to do stuff properly. Like this OECD, this is a massive, it's massive. It has 3,000 observations and it has 48 variables. I don't need all that, right? So what I'm gonna do is first of all, I'm gonna rename a few things. So, this has a bunch of variables. It's called time period, and that's kind of inconvenient. So I'm gonna change that to year, and then these observation values to value, and then transaction to variable. So it has, because basically the variable names are whatever the OECD labeled it, and I wanted to customize it. I want to use the names that I would give it. And so this tells you how to rename all these variables. Okay? And then I want to use Korean data, right? And I have that information here, filter for Korea, right? And so this is what it does. So if I run this command, it's going to basically rename some of these variables. Then I'm going to tell it to, okay, I only want the year, the variable, the value, and the reference area. And then I'm going to filter for the reference area. And I'm just going to do the Korean data for now, okay? So that makes it much more manageable. Now I have 130 observations and 4 variables. If I click on this, it's much easier to read. I don't even really need the reference area anymore because I'm just doing it for Korea, okay? But here I have gross domestic product for all these years, and then the gross capital formation as well. Okay. Now I can also have it arranged. This is the stuff that I want to I want it sorted. So here it knows that I want to order stuff by year and by variable. So I've done that. Now, in fact, I don't want this reference area. I'm gonna make this selection one step ahead. Okay, so I'm gonna filter. So I want to rename these variables. I want to filter by, filter just means that I just want to like the Korean data, and then select is I'm keeping the year, the variable, and the value, and I'm gonna drop everything else that I don't need. Okay, so let me run that again. So now when I look at this data set, it's, from 1960, I have both investment and GDP, and for 1961, all the way down to 2024. Okay, so now for the sake of time, so this is, load GDP deflator. I'm gonna bring in some of these. All right, so I'm gonna read in, and again, the OECD deflator, so it has like 2,000 observations and more than, almost 50 variables. That's because it has like a bunch of junk that I don't need right now, right? This has data for all the countries. And again, this was like a simple, developer API. You just need to do it once where you go in and you select all the things that you want, and then you read off the developer API, and then it's just one line of code, and it downloads everything for you. Again, I want to do something similar, which is I'm going to rename some of these variables, and now it understands that I want to filter. I want the filter to come first, then I select the year, variable, and value. That way I don't have to carry around the ref area, and then arrange. Now, I like to actually have it arranged by variable and then year, because it's just more natural for me that way. And I'm going to do the same thing over here. Okay, so I'm going to run that. Okay, and now it's something much more manageable. I have the deflator, the GDP deflator from, I have the GDP deflator from 1960 all the way to 2024. Okay, and then for Korea, so I don't have the name of the country anymore because I've already commanded it to only choose Korea. Okay. Now, I have the quarterly national account, which has the output and the investment, and then I have the deflator. It'd be more convenient for me to combine that data. Okay, so here I have append deflator data to GDP and investment data, and the command to do that is bind rows. So this is, Copilot's doing everything for me. I'm just kind of telling it what to do. And it even knows that it wanted to spread the data to wide format. Okay, but give me a second. Okay. So I'm going to run this, and so now I have this. It constructed this new data set, OECD data, and again, I'm gonna use this arrange. Yeah, it knew that I want to arrange by the variable and the year. So let me just run this whole thing again. Okay, so now when I open this file, because I asked it to sort it by variable and year, and so if it's numerical, it'll sort it in ascending order. If it's text-based, then it'll just be alphabetical order. So, and you can change that order, but here it's gonna, have the deflator series first, and then it'll list the gross capital formation from, 1960 to 2025, and then it'll have the gross domestic product, GDP, from 1960 to 2024. Okay. Now, it's more convenient to have like the, one set of years on one column, and then like GDP, investment, and deflator as additional columns. So that's called wide format. And so, and in fact, Copilot actually suggested that I spread the data into wide format. So see how it's very good at this, all right? So what it's doing is it's gonna create a new data set, OECD data wide, and it's gonna use this pivot wider command. So let's see how well it does. Okay, all right, so this is beautiful. I have the years, this is exactly what I wanted. I have the years on the first column, then I have the deflator, gross capital formation, gross domestic product on each of these columns. Very nice. Now, I am going to want to rename some of these things. Okay, and then it's kind of guessing that I want to, do some of these things, but it's not going to be, because right now when I go into OECD data, this is not the way it's saved. So this is gross domestic product, and it doesn't have this volume thing. So, if I run it, it's not going to understand. So here, and it's actually not real GDP, it's just nominal GDP. So I'm going to call this NGDP. And then gross capital formation, because it's not actually reading any of my data. It's just thinking, it's just predicting what those variable names might be. So that's why these are wrong. It's not that it's hallucinating, it's just trying to do the best as it can, because it's actually not reading my data. So, and then this one, I'll just do a nominal investment, INV. And then this is the deflator. And I don't want this like parenthesis, like rebased. Okay, so here I'm just gonna say deflator. Okay, and so I did all that. Okay, good. now I'm ready to construct real GDP and real investment, right? So here we go. So, of course, you have the deflator, so and it knows how to do it. So, not only does it know how to code, but it understands economics, right? So how do you construct real GDP? Well, you take the nominal GDP deflator, you take nominal GDP, you divide by the GDP deflator, and then you multiply. So let's change that. Deflator times 100, okay? And then and then it'll understand this is see how it understands that this is the way I want to write it. I want to do nominal GDP divided by deflator times 100. Even though what it suggested was accurate, it would have given the same result. It's just not the way that I would have written it. So I'm just telling it this is the way I want to do it, and it understands. Okay, and no, I don't want to select. So here it's thinking I want to get rid of the nominal GDP and the deflator series, and that's why it has select. Right? This means that it will drop the stuff that I'm not selecting. But remember, in your problem set, I asked you to print the table that has the years, the nominal variables, and the real variables. So if you just blindly follow what the Copilot is telling you to do, you're not going to be able to do that. I mean, you'll have to go back and just kind of try to look for why things disappeared. Okay, but yeah, this is not something that I want to do. So I have the real GDP, and then you can always tell where the base year is, because in the base year, the nominal GDP and the real GDP are the same. And so the base year, the OECD base year is 2020. Okay, so this is all information that you need to check in OECD. Like, what are the units? So for example, like in the original CSV file that I downloaded, it probably had all that. Remember, there was like 50 variables, and I just chose 3. But that's because I already looked and saw that the units are like in millions of Korean won. The GDP base year is 2020. That information were in those original CSV files. If not, you have to go into the OECD and check, right? Okay. Now, this is kind of the tricky part, and I had a little bit of fun trying to figure out how to do this. It's a pretty cool part because, here what we need to do is, remember, we need to construct the capital stock, and then we kind of update our initial guess, and then we have to keep doing this until we get to until it converges. And so, of course, there's a very manual and slow way to do it, but there's a very fast way to do it. And so it's about figuring out how to do that, all right? So I've provided here a very detailed set of notes here. So estimate the capital stock using perpetual inventory method using the following steps. Assume initial capital stock in the first year is 3 times real investment. Okay, so let's do that. Okay, so it's suggesting some things that are, that are fine. It's just not the way I would want to do it. So I'm going to get rid of this stuff. So I'm under OECD data wide here, right? Okay, so I'm going to create a variable called K stock. Okay, this is the capital stock, and for now, I just created the capital stock, and it's just all zeros, right? Because I haven't updated it yet. Okay, so I just created this new variable. Then I'm going to set the first year, the K stock with these brackets 1. That's just going to change the first variable. I'm going to set that to 3 times the real investment in the first year, right? It's useful for me to know how many rows there are, right? So I'm going to store that information in NY, okay? So I have these variables down here. NY is equal to 65. So I have 65 years of data, all right? Now, I have the next step is to calculate the capital stock for subsequent years. Well, let's see what it does. Okay, it says it's guessing that I want to use a depreciation rate of 0.1. Okay, I'm going to use 0.05. Okay, so and actually I'm going to use these. I'm going to put these up here at the top. So it says set depreciation rate, which is fine, but I'm actually going to set parameter values because I want other parameter values in addition to the depreciation rate. And it somehow knew I wanted to be 0.05, even though before it said 0.1. Okay, great. All right. And so let's see how this did. All right, so this is storing in the data set. It's going to update the K stock for, this. So this I is just like a dummy variable for 2 to 65, because I have 65 rows. I already set the first value. From 2 to 65, it's gonna do that in that order. So K stock, it's gonna update this K stock I equal 1 minus delta You see how I said just use the perpetual inventory method, but it has the exact formula that I had in my slides, right? It's just 1 minus depreciation rate times whatever the capital stock was, the undepreciated part of the capital stock, and then it's going to use investment. It's going to do this. Okay, so now I go over here, and then it has this capital stock, right? This capital stock. Because I initialized the first capital stock, and then I have the real investment series, and then I told it to fill out the rest using the perpetual inventory method. So I have this capital stock. But this depends on me getting the initial capital stock correct. Okay, I haven't checked whether this is reasonable or not. So next, I can calculate the capital to output ratio, and I can just call it KY ratio is equal to the capital stock divided by real GDP, right? And so that's exactly the way I would have done it. And I go over here, and I see that the capital to output ratio is very low. What does it mean very low? Typically, for many developed economies, this is like 3 or 4. Now, Korea, of course, was not a developed economy in 1960, so it doesn't have to satisfy that. But if I go down, further into time, yeah, it eventually roughly settles in right between 3 and 4. But, the initial capital stock is probably not correct. Okay, so the way that we said we're going to discipline the initial capital stock to see how stable this capital to output ratio is at the beginning. Right? So we wanted to say the capital output ratio in 1960, let's initialize that so that the capital to output ratio in 1960 is equal to the average value over the next 10 years. So let's do that. Calculate the average capital to output ratio of the first 10 years. And it's just we use this mean command. So that's exactly the way I would have done it. Right? So now the average capital to output ratio is 0.65, and we can see in our data set the capital ratio in 1960 is 0.3. So it's just we need to increase our initial capital stock. Do you want to go from year 2 to year 11? So I'm just going to manually change that. I can redo this. And then I'm telling it to update the initial capital stock using this average capital to output ratio multiplied by GDP in the first year. So it knows how to do that. Right? So now it's saying, okay, I want to change the initial capital stock to the average KY ratio times the GDP in the first year. Okay? Now, so I can do this. Right? Okay, so then I have here repeat steps 2 to 5 until convergence of the initial capital stock. Okay, so I'm going to show you guys the kind of the dumb way to do it. And then, so here I've updated I've updated the new capital stock. You see how the capital stock now is higher, and in fact it goes down because I haven't updated the entire capital series yet. I'm going to do that in this step right here. I'm going to copy and paste this in these kind of steps 2 through 5, and I'm going to hit enter. Now it's updated the initial capital stock, and then it's also recalculated the entire capital series. And I'm going to keep going, and you can see this is not very efficient. But it is stabilizing. Okay, this is not the smartest way to do it. Okay, so but it is stabilizing because the capital output ratio now is something like 1.2 in the first year, and you can see that over the next horizon it's about 1.2. Okay, but you can see that we saw that it was kind of in the upper 3s. So because this is a span of 65 years, in fact, you can write down almost whatever you want for the initial guess. By the time you get like 20 years out, because there's depreciation of the original capital stock, the investment, data become more relevant. And so if you have data from 1960 onwards, but you're only interested in like 1990 and more recent times, then whatever capital stock that you guess in 1960 is not really going to matter, because by the time you get to 1990, that original capital stock isn't going to really matter much. It's all been depreciated away, right? And so we're going to see that in a second. Now, I do want to show you that there is a smarter way of doing this, okay? Now, this process of like, okay, I give it an initial capital stock, and then I compute the capital series. I'm going to make that a function, okay? So, and I've already done it here, but I think you guys, it'd be useful for you guys to figure out, how you might do this. So I'm just going to copy and paste this here. So it's just about understanding the syntax. Like this is a function called build k, and then this is kind of the, K0 is the initial capital. I'm going to supply that capital stock, And then it's just basically, if for an initial capital stock, it's gonna calculate the capital series. That's all it's doing. Okay. So once you've learned the program, it's just so much easier to then, maybe you want to do a different kind of analysis. Maybe you want to do it for a different country. Maybe you want to do it for multiple countries. It's just so much easier if you have this all written out, and if you know how to use it. It's a really, really great tool. Okay, so let me just run down the steps here. What it's doing is, I'm going to do this many, many times, and I'm going to just do it automated. I'm going to use this for. So it's going to just go through this iteration number. It's going to go from 1, and I can set this max iteration to whatever number I want, right? I can set this to 5,000, for example. It says 1,000, okay? And then there's a tolerance. I want the change in the, whatever I'm targeting, let's say the capital to output ratio. I want to keep doing this until it meets some tolerance, like the difference is small enough where I can claim victory. If it's 1e minus 6, that's a really, really small number. You won't even be able to tell the difference. Okay. Now, I have this function where I give it the initial capital stock. It builds the capital series. Then what I'm going to do here is, this initial one, this is how you call the function, right? You call the function, you already have a guess at the capital stock, and then when you run this function, it's just going to, update the capital series. So this iteration number, again, it's just an index. I'm going to start from 1, and I'm going to have it run all the way to 1,000 or 5,000, or how many number of steps it takes. And then what I'm doing here is I'm saying, okay, given the capital stock, compute the capital to output ratio, and then, update the capital stock. These are the steps that I already had written out. And then, once you get your new initial capital stock, see how different it is from the one that you had just guessed, and see if that's less than this tolerance of 1e minus 6 that I set earlier. And if so, then stop. And then, tell me whether this converged or not, and how many iterations did it go. So I'm going to run this entire code, and let's see how well it does. Okay, so see how it converged in 49 iteration. This is from the original, capital stock guess of whatever it is, 3 times investment. That was the initial guess, right? And then it took 49 iterations. But you see how it took a split second. Let's just do it like a plot, like a quick plot. Plot the capital stock time series. It predicted exactly what I wanted. Maybe it is listening. I don't know. That all looks fine. Okay, so let's plot this. Oh, that doesn't look correct. Oh, it wrote the words estimated capital stock. It's clearly not what I wanted. All right, so. Okay, so let's look at this line by line. It used the ggplot command, and this is the data set that I'm using. I do want the year on the x-axis. That's what makes it a time series. And then I'm going to do a line plot. The command for that is geomline. And then of course I want the capital stock to be on the y-axis. And then it's saying color. I'm going to use estimated capital stock. Okay, I think that is fine as well. And then, for labels, this is the estimated capital stock over time. That's the title of the graph. On the x-axis, I have years, and the y-axis, I have the capital stock. And then scale color, it's going to say, okay, estimated capital stock equal blue. That is fine as well. Theme minimal, theme legend position. I don't want a label. And then it's thinking I want to use the word estimated capital stock as the label. I don't want that clearly. So let me just get rid of this. And then I think it should be fine. Yeah. Now, there's certain other things that need to be done. I haven't provided it with enough information, right? So this is 5 trillion, but if my memory is correct, these are in millions of Korean won. So what I want to do is, if I can do divide by 1e6, and then here, I'll just want to make sure that it's already in millions, but it's another 1e6. So this is trillions of, 2020 Korean won. Why 2020? Because that was the base year. This is the real capital stock and not nominal. Okay, let's see if it'll allow me to do that. Yeah, it did. Okay. Now, there's some further improvements that I would want to do for the final product, but let's just keep going for now. Okay. All right, so alternatively, initialize the capital stocks so that the first 10 years capital growth rate equals the first year capital growth rate. Okay, so this is kind of something that I wrote using the help of Copilot. It just kind of took a little bit of like back and forth to get there. But here what I'm doing is I'm gonna build an alternative capital stock, but I don't wanna write over the capital stock that I already did, because I wanna keep them both. So I'm gonna call this thing K stock 2. So for a given guess of the capital series, and remember I said it can be any guess. So in fact, I'm gonna use the guess that I already have, which is the capital series that I had that I constructed using the first method. I'm gonna use that. That's what I'm doing here. And then I'm doing the same thing. I'm saying for iteration number 1 all the way to 1,000, I'm going to construct this capital series, but I'm going to construct the average capital growth ratio, and then I'm going to use the capital growth ratio to inform the update of the initial capital stock. So now when I go to OECD data wide, there's the K stock, without a number, and then there's the K stock 2. And this one, I have to print the number of iterations. Otherwise, I don't know if it's converged yet, because my max iter was 1,000. If it goes all the way to 1,000, that means it hasn't converged yet, right? So I wanted to print the number of iterations, which it knows that that's what I want to do, but for some reason it's not giving me okay, now it does. And you see how it's like super smart. It says, okay, converged in iterations, and then it has alternative method, right? So this converts in 215 iterations, okay? So now I don't know whether these look reasonable or not, right? So what I want to do is, and this is part of your problem set, which is plot the two capital stocks, putting labels on the plot instead of the legend. And so let's do that. Let's see how well it does. Okay, I'm going to take this OECD. No, I don't need to do this. No, I'm going to go directly to ggplot, and let's see how it does. All right. So I'm going to do ggplot with the x-axis being the year, and then I'm going to do this geom line, which is the line graph, which is what I want. And so for the first one, I'm doing K stock, which is the capital stock, and the color is capital stock method 1. K stock 2 is capital stock method 2. And then it's going to add some text, because I told it not to use a legend. I hate legends. So instead of legend, I'm going to put directly on the graph these labels. But let me just, not deal with this right now. So I'm going to comment that out. And then I'm going to have, the title is going to be estimated capital stocks, years on the x-axis, and, the capital stock on the y-axis. And again, I want to write trillions of 2020 Korean won. And I need to do this here. I can do it somewhere else, but let me just do whatever's kind of quicker, because I'm going to run out of time pretty soon. Okay, let's see what we get here. Okay, so do you guys see 2 lines? There's actually 2 lines. They're just right on top of each other. Okay, so these are 2 different ways of initializing capital stock, and basically you get the same graph. Okay, now, I said plot the 2 capital stocks, putting labels on the plot instead of the legend. Okay, so it's trying to do that. So let's see how well it does. Now, what it's doing is, it's going to say, okay, label equal method 1. And in fact, instead of method 1, I'm going to do capital output ratio, capital output method, and then this one I'm going to write capital growth method. Okay. Now it needs to know where to put it, so I think it's kind of smart. Basically, it's going to say where x is at the maximum, it's going to put it on the furthest right. And then it's going to say where, this capital stock is on the y-axis. I'm going to put the words capital output method. It's going to adjust it make one go up and one go down. Basically, that's what it's doing, right? And then it's telling also the color. Okay, and then I'm going to turn off the legend. Okay, and then let's see how that does. Okay. Okay, I mean, there's room for improvement. But you see what I did was here I made them a little bit transparent, and then I made one solid line and one a dashed line. So you can now see that there's actually 2 separate lines, and they're just on top of each other. I'm going to manipulate the data here, OECD data wide, and then so it's amazing. So it's thinking that it wants to convert to trillions, so it's doing 1e12. But it doesn't know that the data itself is the units are millions. So I don't want to do 1E12, I want to do 1E6, okay? Yeah, it couldn't have known that the original units was millions of one. Okay, so now that's done, the units are gonna be fine, okay? So now I can just rerun this whole thing, and it's gonna generate this graph. And that looks fine. There can be further improvements, but I'll just keep it like that for now. Now, I wanna do an alternative thing. I just wanna show you guys this. Okay, it looks as if, even though there are two very different ways of initializing the capital stock, it looks as if these lines are right on top of each other, okay? That's a visual illusion. They are not on top of each other, okay? The way I'm gonna show you that is instead of doing this linear scale, I'm gonna show you guys in log scale, okay? Let's see. Now, generate the same plot, but with log scale. And I know how to do that, but I want to show you guys that this Copilot will do it for you. Okay, it needs to think a little bit. So basically, it copied and pasted what I had before, because I specifically said do the same thing. But now it's going to add this thing scale y log 10, and that's gonna make it have it be done in log scale. Okay, so let's accept the suggestions. I haven't looked at all the line by line carefully, which you should always do. And then let me run that. Okay, so now it's in log scale. But here, it kind of zooms in this area because the units are smaller here. And you can see that they're not exactly the same at the beginning. Okay? But even though they weren't the same at the beginning, even though the capital stuff, because they were initialized using different methods, so of course they're different. But by the time you run around to like 1980, they're essentially the same. And by the time you're at 2000, they're not noticeably different at all. And of course, you might have to mess with the labeling here so that you want the average growth number to be a little bit further down so you can see it. Okay. So yeah, just play around with it. This is, like I said, I think it's very useful. Now let me show you why this is so valuable. Okay, set country code. Let's see, country code. Okay, so I did Korea. I haven't done this before, but let me see. Let's just try one more country. I don't know. Okay, this one worked. So this is Canada, and that one worked. Okay, and then clearly this is not going to be trillions of 2020 Korean won, but it's going to be like billions of 2020 Canadian dollars or something like that. That you just need to figure out. I mean, there's of course there's ways to even automate that. So if I select, Canada, then I'll want it to have read in, like have it use the Canadian currency, not the Korean won. And I can have that automatically replace this. And that just kind of, these things, you decide what you want to keep as being manual and what you want to do is have everything be automated. And then, one thing that I didn't do, but I should have, when I download all that data from the OECD and had like 50 different variables, I didn't choose to keep it because for the Korean data, I knew it was millions, but there it has the units. So it's important that if you want to automate stuff, it's important that you also keep those units and then convert it to whatever units you want it to be, right? And then, yeah, of course here, like the title of the graph, it should be Canada and not Korea, but you can also figure out how to automate that as well. Okay, so this is a very, very powerful tool. I recommend that you guys try to learn this stuff, but if you want to stick with Excel, because you saw how like in R, I had to create a function and then write a little pseudo algorithm that does this convergence routine. Like there's ways to do that in Excel as well. You can write script in Excel, it's just a little bit more cumbersome. And so there's ways to, if you're really good at Excel, like there's ways to do it in Excel too. And so if you look at my tutorial that's on the website, it should still be useful. So if you're not ready to commit to learning R, because it is a commitment, you have to, there's an initial investment period because you need to learn how, but I think with Copilot, it's just so much easier to learn these languages. So I encourage you to use that. But again, the Excel tutorial is also on the website. Any questions? All right, sounds good.